Hello everyone, welcome to Scaleway Sessions. I'm Diego, developer advocate here at Scaleway. Today I'm joined by Simon. I can hear myself. I forgot to mute my other tab. I was talking to myself, but now I'm talking to you. I'm joined today by Simon, who is an engineering manager here at Scaleway for serverless products. So, hi Simon, thank you for being here.
Hi. So I'm Simon. Obviously, I'm the engineering manager for actually what is now called Serverless Compute or Serverless Computing to distinguish from serverless databases. But
Yeah.
we'll talk about this whether or not serverless is a sort of umbrella term or any one product. I've been at Scaleway for a year and a half now. In the past, I've run a startup, and I actually did a PhD
Hmm.
just before I joined Scaleway that was about serverless in the context of distributed computing.
Oh
So I've
wow.
sort of done a fair amount of work on serverless in an academic context. It's quite an interesting paradigm as an academic sort of problem, depending on how far you take the idea of serverless. But we can talk about that later as well.
Amazing. So you're the best guest for us to start off talking about serverless.
In theory, yes.
Right. So why don't we begin with the word serverless? Because I remember when I first heard about the term serverless, it was some weird thing that was crossing my mind. Like, is that does that mean that it's only client side? Are we doing only client side applications? Is that some other term for peer to peer? Because no servers are involved. So yeah, let's talk about that. Why is it called serverless?
um, I've often thought about this, what a better word would be, because I don't think serverless is
Yeah,
a particularly good word.
indeed.
Of course, we're talking about servers. Everything runs on a server eventually. Um, the idea is that there's a level of abstraction where you don't care about the serverless. Where you don't care about the servers.
Servers.
And so in that sense, it is serverless. Your mind is free of servers. You
Worryless.
can, yeah, you can worry less. Yeah, something like a bit like when you use an operating system, you don't care about the operating system scheduler. You don't know how an operating system scheduler
No
works,
idea.
maybe, and so you just run your code. So it's in the same way that you don't know how an operating system works. You shouldn't have to care about servers when you use the cloud. The cloud should feel like a big computer where you just say, do this stuff for me. I don't care if you use 2 servers, 3 servers, 10 servers. I don't care how you do the networking between them, whatever. I just want you to run my stuff. And that's like the idea of serverless.
That's a great explanation and summary. My explanation for this is more down to the common man terms. Imagine if you want a hamburger, you can just go to your closest hamburger place, or you
Yeah.
can uh, have a cow or raise a cow, kill the cow, get the meat, process the meat, then also make the bread yourself and all that. So it will take more time.
Mm-hmm.
Just let someone else worry about that and give you the final product, and you just will be billed for that final product and not the whole process.
Yeah. And I guess actually there is a level of abstraction above serverless, which is software as a service, where you get, like if I'm running Outlook on the
Right.
cloud, I don't I don't even know in a way that's serverless to an extreme degree because I have no idea what's happening behind the scenes.
Right. So the difference here will be then the type of use that I'm applying to
Yeah,
it. So I'm
it's that.
consuming a service in that scenario, and in the other scenario, I'm using a platform to offer my services or
Yeah.
upload my application. Right.
And so one of the big problems facing serverless now is actually the word has become so overloaded and so badly defined that it means a bunch of stuff to a bunch of people. And I think I always like to discuss any, start any discussion about serverless by saying what I mean, what we, I guess, Scaleway mean, and then go from there.
That's a good starting point. Yeah.
I
So
have some
then,
slides to that effect if you want
awesome.
to start with them now.
For sure.
Sure. All right. So let's see if this works. Um, can you see those slides?
Yes, we have the slides. There
Do
should
you
be.
now do you now have them in presentation mode?
We have a black screen now.
Oh dear.
And there we have it. Yeah.
And there we go. All right. So the title of the presentation is obviously Serverless 2, What's Next? These are not, um, you know, feel free to jump in. This isn't a sort of end-to-end presentation. But the way I like to frame this conversation is start with the idea of what serverless is. I'm being a little bit grand here in calling it a philosophy, but then serverless 1.0, then serverless 2.0, and beyond. So the philosophy part. As I mentioned before, I like to think about how an operating system works. So when you're running code on your laptop, you write the code, you might install some other stuff, and then you run it. That's your user experience of an operating system. The operating system is doing a whole load of stuff behind the scenes for you. It's managing all these resources, making sure they're shared between applications, making sure applications are isolated, making sure that you have parallelism on demand. You don't have to say up front, hey, operating system, I'm going to need a gigabyte of memory and 2 cores. It
Right.
just happens. And it exposes this standardized interface where I can use a laptop from a different manufacturer, I can use a different operating system. I'm still using threads and processes and memory. Like the core building blocks are still the same. So you can see where this is going. The user focuses on the code, operating systems on the rest. Great. The cloud, totally different experience. I write some code. I then have to provision some infrastructure to run it. I
Yeah.
configure it. Then, when my application gets too big and needs more space, I've got to scale it up. Then I've got to configure all these pipes to connect stuff together. And all the while, I'm paying for stuff that I reserve and I don't use.
Yeah.
So I provision my instance. If it's only 20% usage, I still get billed the same thing at the end of the month. The provider is just giving me this toolbox of stuff, and it's giving me some managed services. As someone who works for a cloud provider, I don't want to be too harsh on cloud providers. Providing that toolbox and those managed services is really difficult, but the
But
user experience kind of is quite a long way from the laptop.
right. Yeah.
Yeah, and so you can see like this is why when I've worked with kind of with data scientists, with people who are on that boundary between developer and analyst or sort of not so techie people, they can run something on their laptop just fine. They can run their model on their laptop. But then once their laptop's too small, there's this huge barrier to entry to running something on the cloud. Even just running the thing you ran on your laptop on the
Yep.
cloud is difficult. You've got to learn all this terminology. You've got to learn about permissions. You've got to work out how to get your code there in the first place. All this stuff
Yeah.
is difficult.
SSH into it, then protecting your machine, then being able
Yep,
to access it through the internet if necessary. Yeah.
exactly. So we can say this is not great. Users can no longer just focus on their code. And then voila, the idea of serverless is you write your code, you upload it, and you run it. Then the provider does all that crap for you in the background. It provisions your infrastructure, it configures it, it scales it, from 0 to what feels like infinity. It makes sure you're isolated. Ideally, it would connect up different stuff for you. And then, really importantly, it bills you only for what you've used. And if it's not used, you're not billed. So that's how I see the kind of serverless philosophy. It's basically making the cloud feel like an operating system where you can focus on the bits that you care about. I don't know if that makes sense.
Made sense to me. But if you
Sweet.
folks have any comments or questions, remember, we are always happy to read them.
Nice. So, what does that actually mean? My slides have stopped. I can see the live preview and the slides have stopped. Let me unshare and share again. This bin.
Yeah, you're kind of freezing a little bit. Now, a little bit more. And now we lost you.
Screen again.
And you're coming back.
Wow.
Seems like, yeah, you have some internet issues at the moment.
1 second. 1 second. I can hear you.
Sure.
Let me connect here.
This happens. It's live streams,
Can
live
you
demos, things fail.
Hello.
You're back, and you're
back.
normal. Yeah.
Sweet. Okay. So we just talked about this idea of serverless as this philosophy for building cloud products. What that means in practice is these three principles. And I would say, to varying degrees, many cloud products already fulfill these things, and so hence could be described as serverless. It's got to be easy. I don't have to do all that stuff that the operating system does for you. That shouldn't be your responsibility. So it has to be easy.
Right.
Scalable. I think this is the important part with serverless stuff, is it goes from 0, not something running the whole time, 0. And then pay as you go is kind of part of this scale to 0 thing, like you pay for what you use.
Makes a lot of sense.
Yeah. And so the key thing here is that I haven't mentioned a single specific cloud product. This is just an idea for how to build products. And so back to the point about serverless databases, this is another thing Scaleway has taken on. They've said, look, this idea of serverless is just principles. So we can apply it to storage and compute. Who knows what we can apply it to in the future? But
Right.
you could take something like object storage and say object storage is serverless in this way. I don't have to say what size bucket I want. I don't have to say I want it to run on this kind of server. I just say give me object storage, and the provider gives me object storage. So I think
Right.
object storage was the original serverless product, personally.
Huh.
Or if we go all the way back, Google App Engine was the original serverless.
Yeah.
That, I would say, that was a product way ahead of its time. Google App Engine was all about, here's my code, just make it work. And even going so far back as web hosting with a LAMP stack,
Yeah.
like you could that's kind of serverless in that you don't really care about the host. You just give it your PHP files and then it runs. So yeah.
All right. Now, when you mention storage, and then we see point number 2, scalability, that means that your data should be stored somewhere. So scaling that to 0 means what?
Yeah, that is a very good point, in that with serverless databases, the serverless part we're talking about is the computation on top of the data. So a database has storage, and then it has an engine that runs the queries. And it's
Right.
that engine running the queries that can scale to 0. If you're not running any queries, you don't need the computation, so you scale to zero. But
Right.
as you say correctly, the storage still needs to be there.
So I'm still charged the pay as you go part of my storage.
Yeah. And this is one of the interesting things that for every service, we can think about charging for what you actually use. So if you have a database configured with X amount of storage capacity, do you get charged for that capacity, or do you just get charged for the amount of data you're actually storing on there? And again, this is where object storage does such a good job of being serverless and pay as you go, in that you don't get charged for reserving a whole disk. You just get charged for the keys that you store. So, yeah, I think you're right in that data will always have a cost to store permanently.
All right.
Okay, so if we think about serverless now, the main product that everybody thinks of is, I guess, AWS Lambda. At Scaleway, that's serverless functions.
Yep.
Um, you cannot get away from the fact that AWS Lambda basically created serverless as a word. Even though, like I say, there were serverless-like products before,
Hmm.
AWS Lambda was the pioneer, and it introduced this idea of functions as a service, FAS, and that's become.
Whoops. We lost Simon for a bit. So interesting. He was just about to talk about something really interesting, functions as a service. Let's give it a minute, maybe less than that. In the meantime, please feel free to leave your comments, your questions. What do you think about serverless? Have you used serverless in the past? Do you currently use serverless? Do you prefer any other kind of computing or storage solution? Please let us know. And yes, I'm talking to you. And if you're watching this recording afterwards, ping us back. We are Scaleway_devs on Twitter. And if you have been with us for more than a few episodes, you already know Dan's email. So please feel free to send him an email. I guess I'll have some water. You should too. And you're back.
Really sorry about this.
No worries. We were just having some water. We were waiting for you.
Anyway, sorry. Yes. So this product, Serverless Functions FAS, is the dominant serverless product, and it's what we do at Scaleway, along with serverless containers, which we'll talk about in a second. So functions is basically you give your code to the provider. The provider creates some kind of container or VM image. It configures a way of triggering that, and then it launches it when you want it. That might be if you have an HTTP request, if you upload a file to S3 and then it triggers your function, etc. I don't know if this has been your experience with serverless, Diego.
Well, my experience with serverless started with Firebase functions. Well, I did some lambdas. Then Firebase was so easy for me that yeah, I just kept on using it. I could just write my code and I installed the CLI on my machine, and then I would just call the CLI to deploy it. So it's pretty much like that. However, I wasn't aware of the middle part of your diagram. I don't know
Mm,
if it was building a container, if it was building an image. I just know
mm,
that depending on how I configured it on my config YAML or JSON file, it
yeah,
will just appear and react to an event that I set up. Maybe
yeah,
an HTTP request, maybe a database write or read,
yeah.
whatever. It just worked.
Yeah, exactly. And that's this. This is kind of coming full circle to your original question about servers. You, as a user, just do the code. Behind the scenes, the provider will. AWS is not building a container image; they're building a virtual machine image. But well, they might be building a container. Who knows? Same idea. The provider is doing a bunch of stuff that you would have to do as a developer if serverless didn't exist. So these extra purple steps here that Scaleway is doing, it's just doing the same old work but automated. There's no magic here, really. And I guess that's the myth of the serverless part.
Yeah.
And
I,
ironically, there might even be more servers than you would use otherwise.
exactly. Yeah, that's the confusing part.
Yeah. So, I mean, this basically sums up serverless computing at every provider. This is just how serverless works in the industry. And this dotted line below the user is the key level of abstraction, which is it makes it more abstracted than anything that came before it. In that, before you would have to build a container image and upload it to your Kubernetes cluster. Now
Right.
that dotted line has moved up a level so that you no longer have to build the container image.
Right. And I also think that there's some hidden step between code and building a container image that is providing the code or yeah, uploading the code to my provider, right? Because
Mm,
I could upload a zip file. Then I will need to follow the standards of my provider, or I could just use a generator tool that my provider creates,
mm,
and I will follow the directory structure that they specify. Or
yep.
maybe there's a framework that I can follow,
Hmm.
right?
Yeah,
So
yeah, yeah. Yep.
what do we have there?
So the dream of functions as a service is great if you've got a single file, a single code file with a simple bit of execution. But applications have dependencies. Applications are made of lots of different files. You might have a package manager for your language. At this point, this simple just upload becomes more complicated because you have to do more stuff. You have to give a YAML file, like you say. So serverless framework is a good example of it's a different company. They've tried to standardize the way that you create serverless functions, and this has become one of the de facto things used in the industry. However, that is still writing code, creating a YAML file, uploading it. Something we've tried to do, and there are other projects out there as well, is try and take you a step away from that YAML file configuration and uploading zips and things and create tools that actually just look at your code and then create functions in the background. So there's a project that we experimented with and that's on GitHub, but there are equivalents for Azure and AWS as well. And it's basically you write code with some markup and you say, like, this thing is a function, this thing's another function. The tool then reads your code, extracts it, bundles it up, creates a function, gives you an endpoint. And that's the level of abstraction that I think is really serverless. This bit in between where you have to write a YAML file and handle zips and stuff, when I run my code on an operating system, I don't have to zip up the file. I just say run. So I think, yeah, that's probably the level at which we want to aim for with this.
Right, I get you. So, yeah, I just focus on my application. My application needs to do A, B, and C, and that's it. I don't need to think about the process of me pushing it to my service provider
Mm,
function engine. That's additional thought process that I need to
yeah.
have that I
Yep.
don't want to because I want to focus on my product, right?
Exactly. Yeah.
This tool that you mentioned sounds really interesting. Do you recall the name so we
Yeah.
can Share it.
So, well, it's called the Scaleway. Good question. It's Scaleway API. Scaleway. Oh my god. Serverless. One sec. I will find the link. So it's all under the Scaleway GitHub organization. And so we have quite a few serverless open source repos, which is what I can talk about now. There's the Serverless API Framework Python, Scaleway/Serverless API Framework Python. Now, the reason that the name is so hard to understand is that for every functions thing we do, we need to do it 5 times for each language runtime. So if we have a Python specific thing, it's Python. If we have a Node specific thing, it's Node, etc., etc., etc. So in creating the names for these things, it's not very catchy, but it's there. So it's called Serverless API Framework Python for Scaleway, and it means you can just write your Pythonic code with some annotations, run a command, and it works. And I think that is the level that we as providers should go for users with serverless, because the whole point is it's meant to be easy. Expecting users to do that level of management is probably, yeah, a step too far for some people.
Yeah, yeah. Just focus on what you do best. Just work on your code.
Mm-hmm. Exactly.
Amazing. We're showing the URL down your screen, so you can check out the repo and hit it star, fork it, clone it, have fun with it.
So I'll go on to the next product that is also part of the serverless landscape today is serverless containers. So the way that I think of this is pretty much like the functions diagram, but the dotted line is below where you create a container image. So you as a user write your code, you package it as a container image, then you give it to us, we launch it on demand. The reason this exists is that some people have more complex requirements around their code. So that problem that I was talking about, once you go beyond one source file, more complicated dependencies, you might have some system libraries you need, it becomes easier for users to package their code in a container image and then deploy it. But still the same idea, easy, scalable, cheap. It scales instances of your container up. You pay for what you use. And the only thing you need to do is tell us what the image is and when you want it to run, basically.
What should trigger it, right?
Yeah, exactly.
Got
And
it.
so once again, this is not unique to Scaleway. This is a sort of a fairly common product to all cloud providers. And so that's why I'm confident in saying this is kind of serverless 1.0. To criticize this model, we can start by saying what works well. So as I've said, low or no configuration, no provisioning, auto scaling, and you're built for what you use. That's all good. The reason that I've called this serverless 2.0 is that there's still a lot to do. So these are the general problems that I see with serverless that are not unique to serverless at Scaleway. It's kind of industry-wide problems. The magnitude will vary, but they're all there. So cold starts. If I'm building an API on serverless and I'm expecting it to scale from 0 in response to requests, I'm adding that latency to that first API call, where I make an API call. It has to start a container in the background to serve my API call. This is the classic serverless problem of scaling from 0 doesn't come for free.
Right.
It takes time. And it's such a restriction on certain use cases that it puts people off, because you say, I want an API that responds to user input on my website. But if every so often a call takes a second, 2 seconds, 3 seconds, you can't have users waiting around for that long. So it's a big problem, and it's a technical problem. It's a very interesting technical problem, because how do you go from having nothing to having something running isolated well
Yeah.
with some arbitrary code that might be held in storage elsewhere? You, as the provider, need to get that code. You need to start it. You need to isolate it. You need to make sure it's healthy. Then you need to take the request, respond to it, and give the response back, all in hundreds of milliseconds.
Yeah. Quite a few tasks.
Yeah. So it's a classic problem with serverless. No function to function communication. Because your stuff is auto scaled by the provider, and because of the contract that you have to write your code to allow that, it means that your application has to tolerate being run at any parallelism. It has to tolerate being auto scaled up and down by the provider. So therefore, it's quite difficult to write parallel applications that have different parts that talk to each other, because the provider might be scaling up and down all those different parts behind the scenes. And it makes it, in addition to the fourth point, this awkward programming model, serverless is still quite difficult to write applications for, and you can't just take an existing application and run it on serverless. You have to put in a lot of work, and I think this has been a real blocker to serverless progress in general. And again, I don't know if what you've used serverless for in the past, but I imagine it was for some kind of maybe downstream processing or webhooks or something.
Yep, yep. So my personal website is is served by a serverless function. Test APIs here and there. Yeah, processing images, things like that. And indeed, yeah, you can't just create your service or your server on your machine and running on your machine and then just push it and it will work, because you need to adapt to whatever method the service provider will use to react to those events. So for instance, if I'm using Node.js and Express, I need to tweak my code in order to make it work with my cloud provider. So yeah, that's a kind of a limitation that I see here, that I need to transform my code to comply with whatever the service provider wants.
Yeah, yeah. And that comes on to this final point, slow development feedback loop. And the things that could be better is this offline testing and the development feedback loop. So as at Scaleway, we have created a set of libraries that help you emulate the serverless environment on your machine when you're developing locally. So some more great repo naming here. We've got Scaleway Serverless Functions Python, Scaleway Serverless Functions Node, and we will be adding serverless functions PHP, Rust, etc. The idea is that if I'm using this serverless environment, the way that I have to test is write my code, upload it, wait for the provider to deploy it, invoke it, check what the error is. This is not a problem unique to serverless. This is just the cloud in general. Like, if I'm using any service, my development feedback loop is super slow when it comes to integration. And so one of the things that we're trying to improve with Scaleway functions is to get this offline testing experience really nice, because it saves everyone time.
Definitely, I agree. As soon as I started using one of those offline testing tools, my development workflow improved a lot, because when I first started, I had to push everything, then wait for it to fail, try to figure out why, if
Yep.
there were any useful logs on the platform. So I needed to use my browser to go through the logs, for instance, find out what happened, and then fix it on my
Yep.
machine, push it again, and repeat.
Exactly. Yeah.
And that takes time.
And it does take time. And so, like I say, I've put it in the could be better section because we have made some efforts, but you can never fully create the environment on a local machine. So there will always be that gap between the emulation and the real thing. And making that gap as small as possible is really a goal for us. So I'm actually going to skip this part because we're running out of time. I would just say this is how I sum up the state of serverless today. So you've got this little, I would make the circle with serverless in smaller, but the text wouldn't fit. So it's the Venn diagram of stuff you can do in the cloud on the right, loads of stuff, machine learning, big data, blah, 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 anything you can think of. There's a tiny crossover between serverless and other stuff you can do in the cloud. You can build APIs and webhooks. You can do some kind of downstream processing and workflow stuff, but there's not a huge overlap. There's some things that you can only do with serverless, or that serverless is really good for. Event-driven applications, like we said, you do something and you want something to respond. Cloud glue, i.e. connecting services, that's really good. You have a message on a queue, it comes in, you want to process it and send it to a downstream system. That serverless is perfect for that. That's where I'd say serverless is uniquely placed. What we want to do is grow this circle and also increase the overlap. So we want to build more things that serverless is good for, but also we want to start taking some of this share of the rest of cloud computing, because those original principles of making it easy, scalable, and cheap, we should be able to do that for a bunch of other stuff.
This diagram brings a question to my head. So you have machine learning on the rest of the cloud computing environment. Can we potentially do machine learning on serverless?
So there's a few restrictions. I'd say the primary restriction right now is GPUs. So the great thing about a CPU is it's really easy to share a CPU, and it's really easy to divide a CPU into tiny segments.
Right.
That means that we as a provider can easily run 100 functions on a single CPU, or well, single CPU with lots of cores. A GPU is a lot harder to share. I have to move my data into the GPU, run the computation, and back. GPUs don't have as much hardware support built in for sharing and dividing. It's coming, but it's not there yet.
Right.
So your serverless function using a GPU goes from being something very small, single purpose, short lived, to something pretty chunky and expensive. If you're renting time on a GPU every time, it becomes expensive. It becomes harder for us as a provider. Our fleet of servers to run that needs to be a lot bigger. Also possible. The second restriction I would say is attached storage. So if I'm doing machine learning training, I need a lot of data, and I need it basically attached on a file system. Because serverless is somewhat ephemeral, mounting and unmounting those big volumes becomes more complex for the provider. This is something that we're trying to solve with serverless databases, where you attach storage to your scalable compute. But doing that at the scale of many terabytes of training data on a distributed set of training computations changes the problem. So it becomes potentially a read-write many scenario with large amounts of data.
Right.
Again, not impossible, but just not what serverless is built for today.
Right.
And then finally, the programming model. So often, if I'm writing distributed training now, it might use some kind of message passing, or like MPI, or some kind of collective communication library. Collective communication is built on long-lived processes passing messages between each other. It's a really classic distributed programming model. As I said, with serverless now, serverless functions as they are, they don't guarantee you a level of parallelism. It's quite difficult to build collective communication on functions now, because I can't say, okay, I need 10 functions for 5 seconds. What you say is, hey, provider, here's my workload. Give me
Right.
as many functions as you think I need.
Of
But if
course.
I've got a massive data set, I need to know how many parallel processing units there are so that I can divide my work into that many.
Right. I
It
get you.
becomes super gnarly to write like good distributed training for serverless. Um, so there's a couple of things. So yeah, we have to work out the GPUs, we have to work out the storage, and we have to work out the programming model. They're the restrictions for machine learning on serverless.
For the first point, as you mentioned, and I understand the second and third,
Hmm.
it's really difficult. But you mentioned that things are coming in the future to be able to, if I got it correctly, split or get sections of the
Mm-hmm.
GPU more easily.
Yeah.
Are we talking about near future, maybe H100, H200 GPUs from NVIDIA, or long term?
So the problem of sharing hardware is twofold. There's the hardware support for it, which newer GPUs will provide in the short term. But then there's also the operating system level virtualization, where you can do multiprocessing with an operating system, switching things in and out of CPU cores. The operating system level, I am not so sure. I imagine something like CUDA will come with support for these things. But then once CUDA has implemented it, every machine learning library needs to then also implement this kind of interaction. And so the hardware side might get done soon or be done.
Right.
Then a bit later, it will be available from cloud providers.
Mhm.
But then porting a bunch of software to run on that, I don't know how transparent that would be, and I don't know how long that would take. This is really reaching the bounds of my expertise as well.
Yeah. Then we rely on the community to create everything and wait.
Yeah. Yes. Yeah. Yeah. Or maybe maybe there will be some effort to cross the boundary from providers to help port TensorFlow or something like that. But yeah.
Right.
Anyway.
So these limitations that you mentioned, you specified that were in the realm of training. But
Hmm.
how about inference?
Yeah, so inference is a lot easier, and inference is actually something where serverless is quite well placed, because obviously with inference, you it's like any web service. It has unpredictable load, and what you need is lots of things working, lots of independent things working in parallel on a shared model. So that's pretty good for serverless. Scales up when you need it, scales down when you don't. Um, if the model is small and the computation is relatively straightforward, then you probably don't need that many resources either. And so then again, it could be quite cheap. The one problem again is that storage and the state. So your model in an inference setting will be read only,
Right.
but it still needs to be there in your functions. So when we go back to that cold start problem, I don't want to have to download that model for every inference decision.
Right.
And it will be fun. The way serverless works is you make your first request, it creates the instance for you, and that instance will sit around serving requests. So once it's started up, it's all good. It's just that initial cold start. We would need to, I think, as providers, do a better job of offering attached storage ready to go to every function.
Hmm.
And AWS layers is an example of how you could do this. I like the approach, but I do find it quite hard to use and reason about. The approach I would prefer is more like a kind of mounted storage where you say, for all my functions, slash mount slash model will always be mounted with this data and this drive, and I can
Right.
access that separately. That would be cool. Just like mounting, and this comes back to my preference for looking at things like an operating system. Shared mounts for functions could be really cool, I think.
Right. And they will be read only, right? So
Yeah.
it can be shared. That's of course makes sense.
And then there would be the challenge of making them writable by multiple distributed workers.
Hmm.
But that's another question.
Yeah, it's a challenge for another day.
Yeah. Um, Speak of another day, I'm just going to quickly go onto the serverless 2 parts. This is where I think we're going. We've covered all the problems. For me, it's really about building a whole ecosystem around that original philosophy of what serverless products can be. I've tried to draw it out here. So, like, this is kind of the purple stuff is basically what we've got now. The blue stuff is the rest of the ecosystem that's kind of missing, in my opinion. To create a fully serverless ecosystem, relational storage at the bottom, that's serverless databases. So that's all good. GPUs, we've talked about already. Machine learning at the top on the user side, we've talked about. This division between user side and provider side is basically user side is software that the user uses, and the provider side is the stuff we expose. Um, Workflows is an interesting one. So right now, it's relatively straightforward to imagine I've got serverless function A that invokes serverless function B that then invokes CDE, which all, when they're done, invoke F. That's sort of relatively straightforward. What's more interesting to me is creating a more like a programming model around distributed task. So you can think of maybe actors frameworks. I don't know if you're familiar with actor frameworks, but it's this idea that you have a bunch of distributed workers who can all send messages to each other, and you can do distributed programming like that. Or you can have workflows where the workflow isn't specified at upload time, but it's worked out at runtime. So you can think about this like on an operating system, if I have an application that launches 10 threads, and then after those threads have run, I get the result, then I maybe launch 5 other threads to do this processing and 10 to do this. Or Go routines, for example. Go
Okay.
routines are a really nice abstraction to work with there. Dynamic workflows and distributed computing like that is much more interesting to me, and I think as a programmer, than having to write in a YAML file function A calls function B calls function C. We have that YAML thing today, but I think really the cool thing would be to write code for that new underlying distributed sort of cloud operating system.
Hmm.
Um,
That's
it
a new,
feels very
totally
different.
new approach, right? So it will take some
Yeah,
time for people to adjust to it.
yeah. I think this is kind of coming on to what I would see as serverless 3.0, really. But there's um, there's some work in, well, it's basically the high performance computing world. So if you're a scientist now and you work in a research institute somewhere, you'll have a cluster. You can write a job using MPI, which is this message passing framework, and run it on the cluster. And it will create these distributed workers who pass messages between each other. This is how people use supercomputers now. And that world has existed for decades. People have written programs
Right.
for large distributed systems. And actually, I think what would be cool is porting some of the ideas from the HPC world back to cloud computing and serverless computing, because the problems of writing large scale distributed applications have already been solved and the programming models exist. What's interesting is that the distributed machine learning frameworks now are adapting frameworks like MPI to work for that. So you can Glue is a project. I think it's a Facebook project. It's a collective communication library anyway, and that can run on top of MPI, which can run on top of a large computing cluster. There's no reason why that backend couldn't be a serverless platform from a cloud provider. Anyway, this is getting a bit esoteric now, but this is what I mean by this kind of world of serverless programming models. I think it's definitely what's missing for writing large distributed applications for serverless. And then there's some more boring stuff like batch jobs.
That's the boring stuff.
But it's like there's the bread and butter. Most developers nowadays are not working on training massive distributed machine learning models. They're working on batch jobs, they're working on websites, they're working on vanilla stuff. And actually, as a cloud provider, we can't forget the bread and butter developers who just want something to run a batch job. And this is one of the products that we're working on now and that will come out later this year, serverless batch jobs, where tell us what you want to run and it'll just run each night, for example, or it'll run twice an hour. Tell us the container image, tell us when you want to run it and at what scale, and we'll run it. That to me is serverless still. It's kind of vanilla, but it's making developers' lives easier.
Right.
You can think of it like a cron job on your
Exactly.
laptop
It's
or on
exactly
your
what I was
machine.
thinking, right? The event that triggers it, it's a cron job.
Yeah. So that exists today for serverless functions and containers, which we have. But serverless functions and containers are kind of resource limited and they're short lived. And there's this problem with parallelism that I described.
Yeah.
The idea with these serverless batch jobs is that you could specify a fixed level of parallelism and they could run for 3 hours if you want. And they could use a GPU if you want. This is really the kind of larger scale serverless computing that we foresee.
I was just thinking as a regular user, as a regular developer, that it will be interesting for me to just be able to program my job to run whenever there's the least demand on the servers so I can be
Mm-hmm.
charged less because why
Yeah.
not?
Yep.
But yeah, that's my user mind
Yeah.
here.
Yeah. But I think that's the distinction that we want to draw between the kind of serverless we do today and this sort of batch job, more asynchronous world, where if you're running something overnight, you don't care if it runs at 3 a.m. or 5 a.m. And it opens up this more interesting thing that you're describing, which is you're giving a lot more power over to the provider to decide when to run it, but you can give a window. And we could,
Yeah.
do it when it's cheaper. A thing that I'm really interested in personally is doing it when it's greener. So when the energy mix in the grid is better
Yeah.
or more green, we could say, okay, we're going to run all your batch jobs at 5:30 a.m. in this data center availability zone because we know we get a good energy mix there.
Definitely, and that helps
Mm,
me to offset carbon on my end as a
mm,
client, right?
yeah. And I actually foresee, oh yes, total tangent, but I foresee serverless has a lot of potential to improve.
We were just getting to this important part where he was just going into a tangent. But if things work the way they did a few minutes back, it will be less than a minute. So, what a refill.
Sorry.
And you're back.
Yeah, basically, if you're going to pick a green cloud product, serverless has got the potential. Um, so there we go. I'd say that's pretty much. I hope that gives an overview of what we see as serverless and where it's going to come from, what we got now, the restrictions of what we got now. I didn't want to sound too negative. Serverless does a lot now, and you've seen it's really difficult for providers to just do serverless one, but serverless two can be so much more. And I really want to encourage that idea that it's not just one product, it's not just compute, it can be this whole ecosystem.
Great. Yeah, yeah. You opened my mind to many
Thanks.
different approaches towards serverless. I honestly didn't think too much about databases or storage in general being part of the serverless ecosystem, even though I've heard about the term serverless database. I
Mhm.
just, my mind just stuck with functions and probably containers. But yeah, this way of thinking, this initial presentation that you did about the concept of serverless cleared
Mm.
up a lot of the concepts in my mind. So thank you for that. Thanks for the whole conversation. This whole chat has been amazing. And we didn't even talk about the technical aspects of serving serverless products. And that's, I think that's an interesting topic that we can cover in the future. Like,
Yeah, yeah,
how do we actually serve our serverless products? Do we use what? Are we using
yeah, yeah, yeah,
Knative? Are we using images here and there? Are we
yeah, yeah.
just using bash scripts?
Hmm.
Right?
Yeah, and the challenges that come along with that. I
Exactly.
think that's definitely worth a round two. I can certainly talk about how we do it, and there's a lot of research on how to do it better. Because fundamentally, some of the products that we have today are just not built for this. But products don't exist for doing it really well. So it's a fascinating area of research.
Amazing. All right. So yeah, we have come to 1 hour already. Thank you so much, Simon, for joining us today at Scaleway Sessions. We will be glad to have you once again in the future.
Cool. Thanks.
Thank you, audience, for sticking with us for this whole hour. We hope to see you soon. Bye bye.